Good evening, everyone. I hope you can hear me. Uh,
Yes,
can
sir.
anybody? You can hear me, right?
Yes, sir. Very good evening.
Okay, okay, okay. All good. Uh, so uh, today we are having a problem solving session. Basically on the course MATLAB programming for numerical methods. So this is a 12-week course, as you all know. There will be lectures uploaded for each and every week. Uh, you'll probably get a mail that uh, uh, things have been uploaded, and you can watch them every week. And there will be assignments at the end of the week. You have to solve that assignment, and at the end of the course, you will have an online exam for which I think you have to register and pay some fee, and then you will be certified. You will get an NPTEL certificate. So this course, as you all know, is taken by Professor Niket Kaisare. So he is a faculty in Department of Chemical Engineering, IIT Madras. Okay. So coming to my introduction, my name is I am the TA of this course. You can say teaching assistant. My name is Syed Shabir Ahmad. So I am from Department of Applied Mechanics in IIT Madras, and I'm a PhD scholar, a PMRF scholar in the Department of Applied Mechanics, IIT Madras, and uh, and I have done my bachelor's in civil engineering, and after that I have gone to do master's in structural engineering from IIT Bhubaneswar. Subsequently, then I have joined here for my PhD. So this is my background, and if you have any questions related to the course, uh, like if you have any doubts or something, you can probably write a mail to me on this email ID, or if you can't reach me through this, you can also uh, uh, use this. This is a dot. So you can use any one of this mail, and you can write a mail. Probably if I know some about the thing which you are asking, or if I don't know, I'll try to know, and I'll get back to you. So uh, this is the basic introduction. So I want to know, I don't know the background of the people who have joined here. So uh, I assume that most of you are from engineering background. Uh, can I get a hand raise if you are from engineering background, or probably you can write. Uh, yeah, yeah, yeah. So it's like most of the people, or I guess from engineering. Uh, are there people from basic sciences like physics, chemistry? Uh, okay, 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 okay. So we have a wide range of audience here. Okay.
Excuse me, sir.
Yeah.
Yeah, my name is Srikanth Rao. I'm also a
Yeah.
scholar in Suresh Gyan University, and I am also working in KPCL, Karnataka Power Corporation Limited, Nagar, since from 22 years. So
Oh, great.
just I had completed coursework in PhD. So I think I am also doing some AI and ML technology, means
Okay.
artificial intelligence and machine learning. So that's why I selected this subject to
Ah,
learn
okay.
deep regarding
Okay.
analyze all those things. Yes, sir.
Okay. Great.
Sir, one more request from maybe our student side. Please
Yeah.
upload the this recorded videos within one day. It's helpful. So we're
Yeah.
taking
Yeah.
2 3 days or more than. So it's
Yeah.
yeah, it's
Sure,
good.
sure. I'll upload as I finish this session.
Yeah,
I'll sit on it, and probably by midnight this will be uploaded.
yes,
Because this is a very long video. It also takes time. So
yes.
it depends on the internet connection and all. So
And
I'll
uh,
upload it.
yes,
Uh,
sir. And at
yeah.
the same time, sir, how where we want to open that one link? Can you show? Sir?
The To get the videos, right? Uh,
Yes, sir. Videos.
yeah. So you can. Okay, I'll do one thing. Uh,
Better to
I'll
show the
I'll
present.
just I'll just share you the link of my YouTube channel. All the videos will be uploaded there. Okay.
Sir, what about an portal? Will not get any portals?
Yeah, portal also you can get. That is also an option.
Yeah.
If you want to directly access, you can use this link I have shared in the chat box here, chat box. And like okay, if you can you see the screen now? Uh, you can go to Swayam and you can log in here. If you have logged in, and you can go to your courses and you go to the course. So in the course link, you can see here there are different sections: course outline, module 1, module 2, text transcripts, downloading the videos, books, lecture material, and in the bottommost section is the problem solving section, Jan 2025. If you click this, you can click the link here, and it will redirect you to this Google Sheet. And from here, you can access it. I'll upload the YouTube link here, and also whatever I have presented, the codes or something, if I have written, or if there is a presentation, I'll upload it here. I'll also put a Google Drive folder here. So from this, you can get the uh, access to files and also the YouTube lectures. Okay,
Okay,
that's
sir.
how we are going to go.
Yeah,
Yeah.
yeah. Okay, sir. Because already 2 class they took, but I
Okay.
have
Okay.
seen the same up to this. It is blank is there, so that's why I'm worried, sir. Okay, sir.
Okay. 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 Probably, I think they'll upload. I'll make sure that I'll upload as soon as possible. So we are going to learn MATLAB here. So uh, two people have raised hands. If you want to ask any question, you can unmute and ask. Otherwise, you can go ahead. Okay. So we are learning. We are going to learn MATLAB programming here. So why do we need to, the first and the main question which we have to ask, like if you are a very beginner and just starting out your programming journey, since there is like very less material to cover in this week, I thought I'll share some of my experiences in programming and why we have to learn programming and how to write efficient codes. Like I'll give a brief intro and then we'll go and look at some examples and do some MATLAB coding. So, uh, so programming is like basically you are trying to give instructions to the computer to perform a particular task or to solve a specific problem which you have. So if I can tell you an analogy, like if you want to tell a robot to do a particular task, so what you will do is you will try to tell the robot, let's say you want to make a sandwich, then you have to tell the robot in a particular way so that it understands the problem completely and performs it according to the instructions which you have given. So first you will tell it to take the bread and collect the required materials and then make the sandwich. So it's like the recipe. So you have to tell each and everything. What are the materials required to make it? What are the things required to make a sandwich? And how much if you're going to cook, how much time you have to cook? What is the heat? All the different things. If you give step-by-step instruction clearly, it will perform the task as efficiently as possible. So if something is missing in your instruction, then it will do something which you can't imagine, like whole of your dish will be destroyed. So whatever the languages which we learn they are basically computers language. So MATLAB or Python or Java or C++ or whatever the programs which we learn are computers language. So we are communicating with the computer and telling the computer in its own language which it understands to solve a particular problem in a step-by-step way, giving clear instructions what to do. So earlier, whenever the computer, like the oldest computer you can say, so people had to write this assembly level languages or machine code. So these are called low level languages, assembly languages or machine code. Low level languages. So it's like these assembly level languages or machine code. What it does is whatever the instructions which you have given, it will try to communicate with the hardware of the computer. Hardware means whenever I say hardware here, you can assume it as a CPU. So CPU is also there and also memory processing unit or your hard disk. Everything is called hardware. So hardware is the thing which is performing. So you have processors in your computers and also mobile phones. Those are the things which are performing your tasks. So you have to communicate with the processor. So these assembly level languages used to do these things. But the problem is like each and everything you have to specify. So CPU has like lot of registries, like you have to tell the each and everything where it should be stored in a specific registry in the CPU. And like it's like very tiring to write that code. It's like very big. And also whatever the assembly code which we write, like the computers don't know what the languages like which we use. So it's like the computer understands this kind of language, like a binary code, like zeros and ones. Whatever you write will be converted into this, and it will perform operations, and then it will convert into your language which you understand, and then we will be able to get the output. So these are low level languages, and after that the development went ahead, and also people started proposing high level languages which are built on top of these assembly level languages or machine code. So high level languages, maybe I think from 1950s and 60s, the development started. Like there is C++, C, Java, MATLAB, and Python, all these things. So and also there is Fortran and C++. These are like you can say old high level languages, and like if you go to MATLAB and Python, so those you can say like modern high level languages. So the thing again with this Fortran and C++ is these are also very like these are very fast, like to perform computations very fast. But the thing is, writing the code is like very difficult, or you can say uh, heavy code. Like you have to write like a lot of lines of code. So like it's like if you want to write like for a simple thing, you have to write multiple lines of code. So then what happened is like people again started to build uh, on the top of this like more high level languages, MATLAB and Python. So what these languages have done is these have still reduced the effort which is required to write to do programming by reducing the lines of codes, and also they have like specific libraries, functions which you can directly call and use in your program, so that you don't have to write the code again, and also you can write, you can run a single code multiple times. So functionality has been improved. So but these high level languages are not as fast as uh, computationally efficient as uh, uh, these languages like Fortran and C++, because like whatever the high level code language code which we write, so there is the code, and then it goes into a compiler which which does convert your code into machine code, and then it performs the operation, performs the tasks, and then after that getting the output, uh, it again gives you the output in a form which you will understand. So this is the thing which is going on in the background. Like whatever the things which we are using today is entirely written with some kind of code. Like if you take Microsoft Word or Excel which you use, like those are built. Those are built on top of some languages. Like Microsoft Word is built on C++, Excel is also built on C++, Python, and also some front end, back end, lot of things. Like entire everything which we use is beautifully like a lot of hard work is went behind it uh, to build that, so that you can use like using the graphical user interface which you have. Like you can just click a button, and in the background computations are performed, and you don't have to do it. But if you want to solve a particular problem in engineering, or like if you are doing some scientific research, or if you want to solve a complex problem, then uh, then you have to write your own code. And because like we cannot solve the problems like in school or in bachelor's. We might have solved lot of the problems which we had uh, by using pen and paper. But when you go to higher studies and when you start solving complex problems, things become like very difficult to solve by pen and paper. Like you cannot like it will take sometimes days and years. Some kind of problems are there. So what we do is like we try to write a code and we'll tell the computer, okay, computer, I have this problem, solve this for me. So computer does this very efficiently because it performs computations in a very fast manner. Like in this age, like we have like very super fast computers, like whatever the processors which you are getting, are like computing power has increased like in an exponential way. So efficiency of problem solving is increased. So it's it is this thing we have to like appreciate while using while programming, that it is making our task very easier. So I know mm, uh, like all of you will be using um AI tools like ChatGPT or Perplexity or whatever a recent model by Chinese firm called DeepSeek. So all these things you will be using, and like it's nowadays it has become very easy to generate code. It's like just you give a prompt, you will write a code for MATLAB code for this. It will give you a code, and you can directly put it, copy paste, and you can run it. You'll get the output. It has become very easier. But the thing is, like, if you, I would suggest the thing I would suggest is don't use that. Don't use these AI tools while you are solving your assignment problems, or you are when you are practicing, because the thing is, whenever you have to whenever you are learning, your learning should be very thorough, and it should be difficult. Otherwise your mind will not get trained to do these things in a very efficient manner. So programming is not like remembering things. It is breaking the problem into various steps. It is problem solving. So you have to have a logic. So logic is very important. So logic means step by step division of the problem, and just the language is just a medium to communicate with the computer. So you can, like, if you learn a programming language, probably you can learn other programming languages also very easily. Like if you are learning MATLAB for the first time, Python will be very easy for you. Then you can switch also to other languages. The thing which you are learning is you are learning how to solve problems by dividing it into various steps, and you are trying to develop a logic for your problem. So I would suggest, please don't use AI tools. Even if you are using, I mean, probably you you can use, but you just ask it for the syntax of what is this syntax, and like if you are getting stuck in something, like if you are not understanding a particular line of code, you can copy paste and ask ChatGPT like what is this thing. But I would request you to write your own code. Then only it will be very easy for you. So these tools are like you assistants for you. So whenever you learn and you will become very proficient, you understand MATLAB what it is going through. You can use it as an assistant. Like you don't need to, like if you know everything, you don't need to start like write the code. Uh, Each and every time, like you can ask, probably you can ask like ChatGPT, what is the syntax for loop? I have to do this iteration. So it will give you a code. But the thing is, that time you understand everything. So you understand whatever the code it is given by ChatGPT. The thing with ChatGPT is like if you don't give it particular, if you don't give the prompt properly, so it will give you a code which won't work for you. And if you don't understand the code which it has given you, things will go very messy, and you have to uh, you have to again uh, you have to write your code. So it's better to learn first whatever is being taught in this course, like try to code on your own, and then go after you have learned everything, and then you can use the AI tools. So that's my 2 cents on how to use AI. So otherwise it will become very difficult for you. So here in this course, MATLAB programming, uh, we are going to learn MATLAB, but it's not like MATLAB. If you want to learn, like you can look at a lecture and you can learn it in like 2 to 3 hours. Some basic things if you learn, you can after that if you code on your own, you can like do learn it more while doing it. So, but we are using MATLAB for solving uh, or for learning numerical methods. So whatever the problems which we have in which we get, they cannot be solved like most of the problems or complex problems. They cannot be solved analytically. So analytically, when I say analytically, if you have a closed form expression for something, if you something if like you are solving, let's say if you have an integral x dx, you know that this is the solution of it. So you are getting a closed form expression for this. Or let's say you have uh, you don't have limits or you have limits. You know this is a simple integral and you have an analytical solution for this. But the thing is, like if you have some complex integral, let's say sin x, tan x, sin x into tan x into some cos hx dx. So if you have this kind of a problem, probably you won't have analytical solution for this. So you cannot solve this analytically. You won't get a closed form solution for this. So then for these problems, what we do is we try to go for numerical methods. Whenever we can't solve a problem analytically, we go for numerical methods. So numerical methods is, so what I do is, so I know that integral is nothing but the area under the curve. So I will have some limits here a to b. Let's say this is my a and this is b, and let's say this is my function f of x. I am plotting it here, sin x, tan x, cos h. Let's say I'll get this kind of curve from here to here. So what I'll do is I'll try to find the area bit under this curve, and area under this curve will give me the integral. So numerically, when I solve this, I can use lot of methods which are there, like you have the trapezoidal rule or the Simpson's rule. All these different kinds of materials have different kinds of methods are there. So what I'll do is I'll try to divide this entire thing into small strips, and I'll try to calculate the area. This is dx, small strips, and I'll try to calculate the area of the small strips, and I'll numerically sum the area. Okay, so f of x into dx. So these are rectangles, small rectangles, and like if I divide it into small rectangles, and after that if I sum it, I'll get a some answer which is like not exact. It's not the exact answer, but it is very close to the true solution. So numerical solutions will give you approximate solutions. So the thing with this is like as like the rectangles which I am taking here, if I take like smaller, like if I go infinitesimally smaller, like if my dx width of this rectangle is like going very small, like going towards 0, I'll get a more closer or more closer answer to the actual solution. So this is what approximate solutions do. So numerical methods do. So numerical methods like there are a lot of numerical methods like you might have come across. As I've said, Simpson's rule, trapezoidal rule, uh, all these are like numerical methods, and also there are like if you are from background of engineering, like you might have, or physics, or you might have heard about finite element methods, and also computational fluid dynamics. All these are numerical methods. So everything which we are going to learn in this course, so which it will help you to learn these advanced techniques also. So this is the basic introduction to the course, like what we are going to do and what you can expect. So it's like when I say MATLAB, like you might know that. So this is a MATLAB is a programming language and also a software. It comes in a software form, like you have to download it. So MathWorks is a firm which develops MATLAB, and like it is not an open source uh, software. So you have to download it and you have to have a license to use MATLAB. So I think all of you have the license for MATLAB for using MATLAB. Otherwise, like there is also an open source alternative called Scilab. So this is, I think this was developed by various people. Now I think Dassault Systems she is managing it. So it is free. It is a free version of you can say kind of a clone to MATLAB, but there are some things which are not similar between Scilab and MATLAB, but mostly things are like similar. Like for whatever we learn, if you don't have access to MATLAB, you can use this. And also, like if you want to use MATLAB but you don't have access, you can also go to MATLAB's website and you can register. You can get registered and you can use it online. So I think they give 20 hours per month access, free access. If you go beyond that, I think you have to pay, like you have to get the license. So these are the things. So MATLAB, as I've said, basically it is the name is derived from these two words called matrix laboratory. So this and this. So everything which we work on in MATLAB has basically like a lot to do with the matrices or vectors. So because data is stored in the form of matrices and you perform your operations, whatever the operations you do, will be using the matrices or vectors or some kind of like you can erase different kind of things. So it was basically developed for academic purposes or research purposes in the 1970s. And like as I said, it is a license. You have to get the license, and they if you want to, yeah, you can use Octave also. Octave also is a similar thing, or open source thing. You can use Octave also. So another alternative is Octave. Or let's say if you don't want MATLAB, or uh, if you want to like let's say somebody said that they want to work in AI, right? So AI and data science, I think Python is the best language for them to learn. Obviously, like if you learn MATLAB, like whatever the things which we are doing, like it will help you. Like nothing is different, but just the language, a few lines of code will be different. Like you will learn the same things if you learn Python also, like you will learn for loop, while loop, all these things. How to write, there are functions, but just a few things here and there, they will change. So Python, if you like, it is an open source project, like, open source language, like anybody can use Python. they can download and install in their computers, and they can use. So Python is also like well developed. It has a very large community. Like it has been from a long time. There is a large community of Python developers. So it's like also widely used for the current trend of AI or data science. Like Python is widely used here. So because it has a lot of support, like they have like people have developed a lot of libraries. Like libraries, when I say libraries, there are like functions already developed by people which you can use directly to do your problem solving. So that is the thing. So open source and open source and also this proprietary software. So proprietary is things like MATLAB are proprietary. So you have to buy the license, or you can use some other alternatives like clones of MATLAB like Scilab or Octave, or you can use, if you don't want, like you can also switch to other languages like C++ or Python. So these are the basic things which uh, I have to say like as an introduction. So mm, now let's go and see a bit of coding. So I'll just unshare this screen. I'll share from my computer. Can you see the screen? If yes, please, can anybody unmute and let me know, like if you can see the screen, it would be
Yes, sir.
okay. Okay, thank you. So I'll just, so this is MATLAB, and I have opened the window. So as you can see, so this is the version of MATLAB R 2023A. So we have this academic use license in IIT Madras. So I'm using that license. And this is how the UI looks, user interface of MATLAB looks like. So basically, this is the current folder which I am working in. There are like a lot of files, so which I have prepared for today's session. And this is the editor. Like if you want to write some code, like you can probably you can uh, do a right click here in the current folder, and uh, you can create another folder, or you can write a script, or if you want to write a live script we will see probably in coming lectures. Like it is just an interactive way of writing code, and you can also write functions, whatever you want to write. So I'll just let's say I want to write some code. uh, I'll just select script. It will give you an untitled file, so you can write like my something like my first code. You can name it as you want. So the thing is, whenever you write a code, it is a good programming practice. If you are writing like whenever you code, like in future, there will be lot of files you have to write. Like uh, your problem won't be solved in a single file. Like you have to write uh, a lot of function files. All these things will come. So we have to basically whatever the project which we are working on, we have to save that in a current folder. Okay, so this is my current project, which is week 1. I have created a folder. week1, and in that folder I have created all these files. So whatever the files which you have for a particular project, you should all save them in a particular folder. Otherwise, you will be lost in searching those files, and everything will get messed up. So, and also whatever the uh, codes which scripts which you write, they should be named properly. Like I have given some names here, like first, fourth, second, different kinds of names I have given here. So whatever the code, let's say you are writing a code for area of circle, you have to give a proper name so that you can identify it whenever you come back. So you have to give like area of circle, write a name, even though it is lengthy, people should be able to understand, or yourself should be able to understand whatever the code which you have written, and you should be able to access it like 4, 5, 6 months later without forgetting what you have written. Like if you give randomly something like some name like first code, second code, like this here, you will get lost. So whatever the code which you are writing, you should name it properly. So I have, as I've said, I have created a script here, my first code.m, and in this I can write my code. So this is my editor. Okay. So this is called the editor of MATLAB. Here you can write the code, and you can write the code, and you can run it multiple times. Okay. So multiple times, and you can get the output. Okay. So here also we can see there is a command window below this. So in command window also you can directly write some commands. Let's say uh, 5 plus 3, like I just want to calculate the value of 3 plus 5. I can just write and I'll get the answer. So this is like in here also you can write, but the thing is like whenever you write a code in command window, like you can't use it again, and also you have to like it will get very messy. So what we do is we will create a script, and we will then after writing the script we will run the script itself. So that's why here we have created different files. So and this is the workspace here. So workspace is nothing but whatever the variables are we have given, and also the outputs which we get are stored in some kind of variables, and you can we can see as we run and also as we write the code, those all will appear here, and you can see also their sizes like and also the values. So we will see how they will look like. Let's say I have given here 3 plus 5 calculated, and it is stored in a variable. By default it gets stored in this variable ans, and the value of it is 8. So if I click and open this, you can see that this is the value, and it is stored like this. Okay. So this is the workspace have all the variables which you have defined, and also the outputs or everything which gets stored can be seen here. So this is how it looks like. So let's just go and run this code. Like I know that you might have watched the lectures, first week lectures, but still we will see how we will revise a few things which have been taught in the lectures. So here I have like in the command window, you can see that there are a lot of things which are already written. If I want to clear this, I'll just type this command CLC, and it will clear. It will clear. Okay. The command window is cleared now. But there are also some variables in the workspace which are there. Like I also want to clear these variables. Now what I'll do is I'll use this command clear, and I'll run it. Everything is cleared now. So whenever you run a code, a particular code, make sure that you write these 3 lines: CLC, clear, and close all. As long as you are not using your previous code, like if you are running a fresh code, please write this first 3 lines here. because otherwise, if you have if you have given some variable here, and if there are already you have declared some variable, let's say if you don't give a here and you have forgot, and in the previous program you have given a is equals to, let's say, 20. It is your mistake that you have forgot writing a here, but the program should not execute. But if you have not done this clear, and there are already a is stored as some other value, it will give some value, and your output will be wrong, and you will think why my output is coming why there is error in my output. So things will get messed up. So if you are running a fresh code, it will be advisable to use these commands, CLC, clear and close all, before you write your program. So close all is nothing but if you have some let's say this is my plot which I have generated. Close all will close this also. So close these windows which plots are something else which we have already generated in our previous code. So I hope this is fine. If you have some question, if you have any questions, you can ask me as I go. So I'll try to keep it as interactive as possible. So the thing is I have used MATLAB during my MTech, and also I have used here also in my PhD a bit. But currently I have switched whatever the coding which I'm doing for problem solving. I'm using Python as my primary language because basically it's it has a lot of functionalities which MATLAB can't offer, and also it is open source. So I'm doing my coding in Python. So it's like this course is also kind of a refresher for me. Of course, I know MATLAB. I have done a lot of coding in MATLAB. So this is I am also revising the things which I have learned a long back. I have in my MTech, I had taken a course on MATLAB, and I have used it to write lot of codes. After that, I think it's been a year or a year and a half. I haven't used MATLAB, but I know lot of things. I have forgot a few things, but it's not difficult to if you know, as I said, if you know the logic, everything is simple. You don't need to mug up everything. Yeah. So let's say in this first example, we have a is equals to 10, b is equals to 5. So we will perform these simple algebraic calculations. So a is a scalar, b is also a scalar here. Scalar means it stores one value. So one value is assigned. A is assigned 10 and b is assigned 5. And we are trying to get this different mathematical operations. We are doing it like addition, subtraction, multiplication, and division. So, and we are storing this in this. Okay. So this is the sum result. So you can see that I have clearly written this is the sum result. So you also, whenever you write your codes, please make sure that you properly name your variables. I can simply write here C, but whenever if instead of a plus b, if there is some complex thing which you are calculating, let's say area of a circle, something you are writing it, and if you give your code to someone else who doesn't have any idea about what you are working on, and if you give your code and they have to run it, and if you have given some random name C, they won't understand what is this thing operation doing. So you have to clearly write things like this, variables should be properly written, described. And also we can also do this commenting in MATLAB. Comments are things which are written for readability or understandable, for understanding of the reader, or so that when they come back and read their own code and try to run their own code, they can know what are the things happening in this code. So in this code, I am trying to do basic operations and variable declaration. So I have given this comment here. This won't be run by MATLAB, but this will be there in my script, just giving me explanation what the programming is doing. So here, after each line also I have given addition, subtraction, multiplication, division. So these are all comments explaining the things which my code is doing. So I have done the operations here. Then you can see that displaying results. So I have written these, whatever the code which I have written below this is going to display the results which I have derived. Okay. So display is a function, as you might have seen in the course. It will give you the result which you have uh, derived from the operations. It will display it on the screen. Okay. So let's uh, let's say I want to only run this part. Okay. Up to here. So what I can do is I can select this part and I can right click and I can use this evaluate selection in the command window. So if you see this, my code is evaluated from here to here, whatever the things which I have selected. So you can see it is displaying sum, which is 15, difference is 5, product is 50, and the division is 2. Okay. Let's say I have done this is, and I want to now run this selection. So make sure that like you cannot run this selection without running this section, because A, B, and C, if they are getting involved in this code, like in the second part of the code, uh, here there are like we don't have A and B and dependencies on what was previously run. So I can run it probably, but if your code depends on the previous things which you have written before the selection, you should make sure that this upper part is run first and then you run the second part of it. So I've selected this. So here I am creating vector and matrices, and I'm going to evaluate this section in the command window. You can see that here this is the code which I have run, and I am getting uh, the second element. This is the vector I have defined. So we have seen that colon operator 1:5. It basically gives me a sequence of number from 1 to 5, and it is stored in a vector. So it is stored in a vector like this 1 to 5. If you don't give any other thing like it basically takes increments of 1 plus 1 2 2 plus 1 3 plus 1 4 and 4 plus 1 5. Let's say if I give something like 1 is to 2 is to 5, then what it does is it will give me a vector from in 1 to 5 in increments of 2. Let's let 1 plus first will be 1 and then 1 plus 2 3 3 plus 2 5. So I'll get like this. So if I just evaluate this section, let's like this you will get. So this is what colon operator does. So we have seen this. So this, and also you can see that whenever we are writing the code after each line, we are giving semicolon. So it is basically to suppress the output, like or echoing of the output. Like you want to stop, like if I don't give it here, if the semicolon, if I, let's say if I don't give the semicolon here, and I'll just run this entire code. I'll from top to bottom. You can see that each and everything, some result is getting printed, division result is getting printed, difference, everything is getting printed. And again, I'm also displaying it. So this, like you won't want to like display or print every output which you get like in your code. So we will suppress this suppress this output, and we will only display whatever is needed in our code. Okay, so this is the basic first example which we have learned. Okay, now let's see some matrices, how we are going to generate a matrix. I'll just rename this. So whenever you run a MATLAB file, you have to make sure that the script has this format. Some name, like name of this file is exp3.m. So .m file. So your scripts should be of this format .m. Like when, like like you might know, like .png, .jpg, or like .docx or .xml for Excel files. So for MATLAB files, this is the format. So .m is the thing which we have to remember. So I have written this code. So I am defining a 4x4 matrix, and A is the matrix which I am going to derive, and I want to create a magic matrix. So magic matrix is something like, let's say I'll run this. So as I've said, I will, okay, I'll just run this. Right click and evaluate selection in command window. And you can see that the command window is like already filled with lot of things which I have previously done. This sum, division, everything. And also you can see my variables from the previous code are also stored here. So it looks very messy. Like I don't want this to happen. So what I'll do is I'll write here commands, three commands, CLC. Like I'll write just, okay, CLC and clear I'll write. So now I'll run this. So this selection I have run. So I am creating a magic matrix. What is a magic matrix is, you can see that the sum of these row elements, like 16 plus 2 plus 18 plus 3, 21 plus 13, it's like 34, right? 18, yeah, 34. And if you count, if you sum this row also, first row, 16 plus 5, 21 plus 9, 28 plus 16 plus 5, yeah, 21 plus 30, 30, it is also 34. And if you count this diagonal also, 16 plus 11 is like 27 plus 6, 33 plus 1. So magic matrix has this property: sum of the rows, sum of the columns, sum of the elements in the row, and sum of the elements in the column, and sum of the elements in the diagonal would be same. So this is a special matrix. Probably you won't need it, but just this is a thing which we are generating. If you want to read about it, like you can go, there is a formula for it, so you can do that. It's a special kind of matrix. That's it. So now you can see that because I've written these commands here, CLC and clear, everything is clear, and my command window is also clear. I don't need to get confused with the things which I have already run before this. So everything is clear, and I can run this, whatever the code which I have written. Okay. So I have created a matrix and I have displayed it done. Now, if I want to access a particular element, a particular row in this, a particular element, or like element at third row and column 2. So this is my third row, and the column 2. This is the column 2. I want to access 7 from this. So if I want to access this, I'm just displaying the result here, like element at row 3, column 2. This is a string, okay? This will get printed in my command window, plus the output which I want, which is third row, second element, element in the third row and the second column will be printed. Let's say I'll select this and I'll evaluate the section. So you can see that element at third row and column 2 is 7. So this is how we access the elements in a matrix. So if you want to get an entire row printed, so if I want to get the third row printed here, I have like display third row and I have given this command. Again, I have like given display like you want like you uh, like you can simply write in this format also, but I have written like this. So you can see a if I want to access the third row, I have to use this command a of 3 comma colon. So 3 is the row number, and in the third row I want all the columns. So colon will give me all the columns in the third row, and it will print the third row for me. So if I want to run this, if I will evaluate this selection, you can get this. So third row, all the columns are printed, 9, 7, 6, and 12. So this is how we are accessing. Okay, if you want to get the second column and a particular column, you can see that this is the second column. And if you want to like get a submatrix from this, like from 1 to 3, like 1 to 3 rows, 1 to 3 rows, and also 2 to 4 columns. So this is the matrix like 2, 3, 11, 10, and 7, 6 I want to access. From this big matrix, I want to get this smaller matrix. Okay. So if I run this, accessing the submatrix, so I have to still display it. So you can see that this is 2, 3, 13. So 2 to 4, sorry. This is the submatrix which I want to get. 2, 3, 13, 2 to 4 columns, 2, 3, 4 columns, and also 1, 2, 3 rows. So 1, 2, 3. So 2, 11, 17, 3, 10, 6, and this is the submatrix which we want to get it. So if you want to convert this whole matrix into a column vector, you can simply give this command a of colon. It will convert this entire matrix into a row vector also. So you can see that 16, 5, 9, and below it 2, 11, 7, 14. So entire matrix is converted into a row matrix. So these are some basic operations on matrices. Let's see some more. So now what we will do is we want to join, like we have two matrices. Now I want to join these two matrices. So that is basically called concatenation. So joining two matrices or two vectors or something is called concatenation. So if I want to horizontally join B and C matrices, as I have said, again in this code also I'll write CLC and clear. Otherwise, things will get very cluttery and messy. So C is a B is a 2 by 3 matrix, and C is also a 2 by 3 matrix. So if I want to concatenate it horizontally, I have to make sure that the number of rows in B are equal to the number of rows in C. So 2 rows here, 2 rows here, it can be horizontally concatenated. If that is not the case, you will get an error. Okay. So I'll run it. I'll see how it will get. So you can see that 1, 2, 3, 4, 5, 6. Beside it, this matrix is concatenated 7, 8, 9, 10, 11, 12. So this is horizontal concatenation. And now I want to vertically concatenate these matrices, like vertically, like B. I have B. Below it, I want to put C. So for that, instead of comma, I'll use here semicolon. So you know that like in a whenever we define a matrix, comma is comma is used for separating the row elements. And if you get a colon, it means that you are going to the next column itself. Sorry, uh, next you are going to the next row. Okay, so comma is like separating the elements in the row. So 1, comma 2, comma 3. Even if you don't give this comma, it will be okay. But if you forget this semicolon and you don't give comma also, it will be printed like a one whole row vector. Okay, so this semicolon does this, it will differentiate between two different rows. So vertical concatenation, like again, if I want to do vertical concatenation, number of columns in B should be equal to number of columns in C. So 2 by T, 2 by 3. So three columns are there. I can do the vertical concatenation. If I run this selection, so evaluated. So 1, 2, 3, 4, 5, 6. These matrices are vertically concatenated. So now, like I want to concatenate, but what I want to do is I want to add a row to add a row below uh, the matrix B, which has like some constant value 10. So all the values of that row should be 10. So what I'll do is I'll take scalar and I'll define the scalar 10, and what I'm doing is concatenate with scalar row. So B colon, because I want to add a row. So below B I want to add vertical concatenation. I'm doing scalar into once means like whenever I have once is a function, it will give me matrix filled with ones. Let's say I have once 4 I give, and if I run it, you see I'm getting a 4 by 4 matrix because I have given 4 here, 4 by 4 matrix, which has all the rows and columns filled with ones. So this is a function which does this. Let's say if I don't want this, like if you want some different size of a matrix, then you can give like this. So 4 comma 2, 4 cross 2 matrix, if you want to generate filled with ones, you can run it like this. So 4 rows and 2 columns. So here I want to do vertical concatenation. So I want to have a row in which the columns are equal to size of B. So okay, so we have defined B here. If you want to know size of some matrix, you can directly use this command. Okay, size of B. You run it, you can see that you will get this is the function size and or the command which you can use to get the size of the matrices. So size of B is 2 comma 3. And let's say if I want to get the columns of the matrix B, I can use size of B comma 2 and run. You can see that I am getting the columns of the matrix. If you use instead of 2, if you use 1 here, you will get the rows, number of rows. So 1 is the rows. For 1, if you are using 1, it will give you the rows, and if you are using 3, if you are using 2, it will give you the columns in the matrix. So I want to have ones with in the row, and the size of it is 1 comma 3. So size of B comma 2 is 3. So if I want to run this, I'll get, so see, you can see that 1, 2, 3, 4, 5, 6, and I have added a scalar vector or a row with all tens here. So I'm multiplying ones with this scalar here. That's why I'm getting tens. Yeah. So this is how we can access the various elements and do concatenation with matrices. And now let's go to another example. Again, I don't want this to be messed up. I'll write CLC. and clear. Okay. Now, if I want to add two matrices and subtract two matrices and multiply two matrices, I can use this arithmetic operations. So, as we have used for scalars also, I have defined these two matrices of 2 cross 2 size of this matrix is xy is 2 cross 2, and I'm doing matrix multiplication, addition, and subtraction. Okay, let's see how it goes. I'll run this evaluation, and thing is okay. What I'll do is I'll cut this part of the code and I'll paste. So from here to here, if I evaluate this, you can see matrix addition and multiplication also. So this has performed, MATLAB has performed the matrix addition, multiplication, and subtraction for us. So again, you have to, whenever you do multiplication, addition, and or subtraction, subtraction, you have to see that sizes of the matrices which you are giving should be consistent. Like if you are going to add a 2 by 2 matrix with the 4 by 4 matrix, it won't give. Let's say I'll add one more row here. I'll add one more column here in this matrix. And let's say I'll run this. It will throw an error. So it says MATLAB says that arrays have incompatible sizes for this operation. So addition cannot be performed. So sizes should be maintained. So error will be displayed here. Based on that, you have to again go and debug the code and correct your code and run it again. So that should be the, like, that's why you have to be very careful while defining it. Otherwise, like some error will be there. So this is a very simple code. Okay. So it will run in few seconds. Like if you have some complex code and if you have written like it will take some hours to run, and if you have done some mistake in the middle of it, like whole of the hard work is gone. Like you will be waiting for the result like 2-3 hours. Your code has has been running from 2 to 3 hours, and everything will be lost. So don't do these mistakes from the beginning itself. Be careful while defining things. See that this should be compatible. Everything should be compatible. Or you can, what you can do is you can always, as I have said, as I have shown, you can always run step by step like code. Like up to this you can run, or like you can say, let's say size of x and size of z. So I'll see. So I am getting the sizes of these matrices, and I'll only run this part of the code first. See this. Sorry, this is why. So I'm getting the sizes of the matrices. Now I know, okay, the sizes are compatible, and I don't need to worry about this. So this is kind of a check which I can do. Like I can get this, I can evaluate the sizes before I go to the next operations. Okay. So this kind of things you can do to take care so that you do your code, what you have written doesn't get messed up. Okay. So this is the matrix, uh, whatever the multiplication switch is there. And we can also element wise operations also we can do. Let's say you want to multiply each element of each element of this matrix, which each element of this matrix, or if you want to divide the each element of this matrix with the corresponding element of this matrix, that also can be done element wise operations. So we can do it, and I'll just run these sections. So these are my results for element wise multiplication and element wise division. So you carefully, like you can see that you are using a dot in front of the operator. It means that matrix, the operations are going to be performed element wise. Element wise multiplication is being done. Star, like dot asterisk will give you the multiplication, element wise multiplication, and dot forward slash will give you the element wise division. And if you want a transpose of the matrix which you have given, like you can use the apostrophe, like matrix variable which is x and which you want to transpose. On that, if you give apostrophe, it will give you the transpose. And if you want to do the inverse, you can use this operation inverse. So inverse of x will give you the inverse of the matrix x. So now I'll do is like, now I'll run the whole code. So different things which I have done, all the operations, all the outputs I have printed here. So transpose of x, uh, uh, inverse of x, everything is done. So this is how like we can do the matrix operations. Yeah. So now like I want to know uh, how many of you are currently like do you have computers like on which you can code right now, or you are just listening to the lecture, like you are just going through the session? How many of you have like the you have VS Code? Okay, you are using Bipin, are you using Octave or something else? Like, you need to have MATLAB or Octave or Scilab. Yeah. So what I'll do is I'll just give some basic. Uh, I'll just give a few problems, and I'll ask you to solve them using MATLAB. So these are like the problems uh, which you have already might have solved in your similar kind of problems which you might have solved in your assignment if you have solved. I'll share the code, but you just try to uh, if you don't have computer also, like if you are not coding right now, so it is supposed to be an interactive session, like where you get hands-on experience, like because I cannot do it, I cannot monitor everyone right now, like probably some people have the access, probably they won't have, but I'll just request you to write the logic, at least in the logic of the code uh, in your in a paper. If you have, write that, write the logic, or also if you can write the code like this is not a very complex code, you can write it. So define a matrix of uh, uh, size 4 by 4 filled with ones. This I have already shown. Filled with ones, and from that get the rank of the matrix. So I guess everybody knows what is the rank. So I would expect everyone to know the basics of linear algebra. So at rank of A, and also length of A. you can just use MATLAB commands length of A, rank of A to get this. So this is a simple code. I think you can just get in your you can just try to uh, write a pseudo code in a paper also, like rank of how you will get the rank. You can define a matrix like filled with ones that you can do. Okay, this I think it's a very simple thing. I'll give a more complex. Okay, so I have this matrix 1, 3, 2, minus 1, 1, 1, 0, 2, 4, 3, 3, 5, 2, 3, 1, 6, 1, 0, minus 1. And 2. So this is my matrix. So let's say this matrix is A. Now give me the sum of all the elements in first column. You can use the sum command and give the particular column. We know how to access a row or a column, as we have already seen. Okay. And next question is rank of this submatrix, which I will get from taking columns 2 to 3 and row 2 to 3 and columns 2 to 3. So basically this is the submatrix. So what is the rank of this? Next question will be like access this row vector in second row and columns 1 to 4. You have to access all these elements which we are given. Second row and columns 1 to 4. So you can just visualize this, like how we are going to access. I'll just whatever we have. Somebody is speaking, right? Okay. So this is your question, like three things which I have asked. We'll, we'll just see. I'll just stop sharing and analyze. So this is the thing. Okay. This is my code. So I have defined this matrix. Now I want to sum the all the elements in column 1. Okay, sum column 1. So you can see that I have defined this variable in such a way that it is understandable that I am summing the all elements in column 1. So, and I have also given the comments for each and every step which I'm writing. So this is for my understanding or for someone who is going to read my code. So readability, making sure your code is readable and understandable is a good practice. It is a good coding practice. So if I run this, as I have said, again, I'll write these commands CLC and clear. What will be the first column? This is the first column. 1, 1, 1, 1, 4, 2, 1. Sum of this is 1 plus 1 plus 4, 6 plus 2, 8 plus 1, 9. So let's say I'll just run it. I'll just remove the semicolon so that I want to display the output here. Okay. If I evaluate this selection, you can see that I'm getting the sum of all the elements in column 1. So as you can see, if I don't put a semicolon here, it is giving me a warning like to like add a semicolon after the statement to hide the output. So basically, we should not display a result like this. Whenever you want to display, you have to display. You use the display command and display it like this. Like it will be a good practice to use this kind of thing because you are giving the explanation to your output in display using the string, and then you are displaying the output. Okay. So I have written something like this: sum of all elements in column 1. So I can give a description like this and I can print it. So if I run this, so beautifully like in an understandable way, I have run that. So you can get an output like this. So similarly, submatrix rank I have to determine. So rank of A of 2 to 3, 2 to 3. So let's say uh, I'll first get this matrix 2 to 3. We'll see what this matrix is, and I'll run uh, rank. Okay, evaluate section. So this is my submatrix 2 to 3, 1, 0, minus 3, minus 3, and the rank of it is calculated, and the rank is 2 here. So rank is nothing but number of independent rows or number of independent columns in a matrix. So I won't explain what is independence of rows and columns, something which you have to learn through linear algebra. Maybe you can do some brushing up if you have forgot. Like go and watch some lectures about the matrices. All these things, rank, inverse, determinant, all these things, we won't be going through. Like we'll directly use like, okay. Now I want to get this row. Like in second row, I want to get 1 to 4. So 1 to 4 means 1, 2, 3, 4, all the elements. So if I evaluate this, I'll get 1, 1, 0, 2. I'm evaluating the second row. So if I want to get this matrix in second row to fourth row from here to here, but I am not. I don't want this first row, first column and second column. So I only want these things 1, 0, minus 3, 3, minus 1. So if I evaluate it, so 2 to 3, right? Yeah, 2 to 3 columns and 2 to 4. 1, 2, 3, 4. Yeah. So this is the matrix which I'm getting. So this is how we are going to evaluate the access the matrices and all. So now let's see maybe another example. Again, I'll share my screen and I'll write. So this is a similar kind of problem which you might have seen in the assignment. So question is, you have defined a, range of x. So a x, let's say x is equals to -4 to +4 in increments of 0.5. So this is my x vector or the range of x, and now I have this f of x, function of x, some function of x, and it is equals to x square plus 1.3x plus 2. And I want to get the minimum of this function, minimum of x. And I also want to find out what is the value of x at this minimum. So, sorry, minimum of f of x and what is the value of x at this minimum. So, now what I'll do is, in order to determine the minimum of this function, one way, we will go into the, like, there might be some other ways also, like, but what I'll do is, I have this range, okay. So in this range, I have to evaluate this function at each and every point in this vector. So at x is equals to -4 to +4, I have to evaluate f of x. So you will get an vector of f of x filled with the values at each and every point of x. So you will get like a row vector like this. Okay. So from all these values, I have to determine what is the minimum. So in these values, what is the minimum I have to determine. Okay. And also, I have to determine what is the index of this minimum value. So in MATLAB, for each and every array, indexing starts from 1. So first element, second element, third element. Let's say your let up to nth element. Okay, some n elements will be there in this array. So let's say you are getting some minimum value. Let's say 4.5 at index 3. So you have to get this minimum value first, and also you have to get this value of the index. So if I know this value of this index, for this corresponding minimum value, I can use this index number and I can determine the value of x at third element, and then my problem is solved. So this is how I have to solve. So this is x of 3. Okay, I'm using square bracket here because of my uh, use of Python. So in Python we use square brackets. Here it's like this curly brackets. So or small brackets. So this is how I have to solve this problem. I have to evaluate f of x at each and every point, and then I have to determine what is the minimum. So to determine minimum, MATLAB directly has a command. You can use minimum of f or f of x, whatever you want to, minimum of the vector which you want to take, and it will give you the value of uh, or the lowest value in that vector. and after getting the lowest value, you have to determine at which value this uh, at which point, at which index we are getting this minimum value. So if we know from that corresponding index, we can find the minimum value of x. So let's see how the code will look. I hope explanation is clear. So I'll just share my screen here. Can see the screen, right? Yeah. So this is the third one. I'll just rename it because as I have said, MATLAB scripts should have this format .m. Okay. So again, I'll write the commands clc and clear so that my command window and my workspace is free of all the previous variables which I have used in the past code. So you can use clear all also you can use, but like we will just see. So I have defined this vector x, which is from the range -4 to +4, and it is in the increments of 0.5. Let's say if I evaluate, let's see how it looks. So you can see -4 and increment of -4. If you add 0.5 to it, you will get -3.5 and -3, and then you will get finally you will be getting 4. So this is how you will get the vector x vector, and now you want to compute f of x at each and every point. So I'll write like this. So at each and every point, because this is a vector, I want to square each and every element of the vector. So that's why I'm using, you can see, dot hat function. So dot is for element wise operation, and this hat is going to power my elements, square my elements. So each and element of this vector is getting squared, and plus I'll get a vector here, and plus the 1.3 into x. So I don't need to put dot here because scalar multiplication is done. If you multiply a vector or a matrix with a scalar, automatically each and every element will be multiplied with that scalar. And also if I am adding +2, I don't need to put a dot here, because if you are putting +2, it means that each and every element in the vector will be added by 2. So scalar multiplication is done. So let's say if I run this, so see, now you can see that you have got all the for each and every value of x, the value of f of x has been calculated here. So like 12.8, 9.7, 7.5, everything, all the values are evaluated. Now we want to get the minimum value from this f of x. So you can see what is the minimum value from this function is, you can see that 1.6000 is the minimum value in this whole vector of evaluations of f of x at each and every value of x. 1.6 is the minimum value. So in order to get this, like I can say this directly because I have this small matrix. If you have like some 100 values in that matrix, you cannot see and tell it, right? So now I'll use this minimum of f of x command or function to get my minimum value. And also I want to get the index of this minimum value. See here the index is 1, 2, 3, 4, 5, 6, 7, 8. So the eighth element is the minimum. Eighth element has the minimum value in f of x. So you have to use this syntax. So in square brackets, you have to first output. So first output, your evaluation of this function will be the minimum value. And after that, comma, you put whatever you write here, like I'm giving the name minimum index here, like whatever you get after this will be the index of the minimum value in the vector. So now now let's say we will evaluate this. We have. So now you can see that minimum value is 1.6 as we have seen, and the minimum index of this minimum value is 8. So one thing is done. So now you want to identify at which value of f of x, so at which value of x, the f of x is giving the minimum value. So index, so corresponding index of x and f of x will be same for the minimum value. So it's like if I use this minimum index and I access this element of x at the minimum index, I'll get the value of x minimum. So if I run this whole code, like you can see minimum value of f of x is 1.6 and value of x at minimum of x is 0.5. So 0.5 because you can see if I run x here, so 1, 2, 3, 4, 5, 6, 7, 8. So this is the eighth element. So 0.5 is the value of x at which f of x is having its minima. So that is how we are going to like code this. Like this is a example, and this is some same kind of example. I think you have got in your this assignment also, I guess. So minima, like similarly, you can also find the maximum. So like maximum also you can find, like instead of min, again writing max here. What is the maximum value of f of x? So I'm not changing the names here. I'm just writing. Uh, okay, I'll change max value. Max. Max. So if I run this, so there is some error here. So what is that? Unrecognized function or variable minimum value. Error in third. Error third is the file and line 15. So line 15, if I go, okay, you can see that I have changed my name here, but I forgot to change my name here. So it's not the minimum value here. That's why it is like a minimum value. It doesn't know, the code MATLAB doesn't know now what is this variable minimum value, because I haven't used it anywhere before my code. So I'm changing it. That's why the error is coming. So the code comes here, runs till here, and it stops here because there is an error. It won't run beyond this. Okay. So now everything I have corrected. Let's see how it goes. So now you can see the maximum value of f of x is 23.2, and the value maximum value of f of x, value of x at which the maximum is occurring is 4. So like you can open this variable, you can see that this is the maximum value, and the value of x at the maximum value is also like that. This is the last element. So 4 at x is equals to 4, I am getting maximum value of x is 23.2. So in this way, like we have to write the code, like each and every step we have to write it clearly, and then we will get the desired output. Like if we mess up something, MATLAB will throw an error and we have to go and correct the error. So now we will see some examples on plotting. So plotting can be done like you have seen, like I think the last lecture of this module week 1 is plotting. So now I want to plot sin x, cos x, and these sin x plus cos x plots. Okay. So if you simply give sin x, cos x, like and plot, if you want to plot it, MATLAB won't give. Like you have to give the range of x first. So define the range of x. So here again, a new thing which we can see is linspace. So linspace is also used to generate a range of numbers. So which is from -2 pi to +2 pi. And I want to get 100 points between -2 pi to +2 pi. So linspace I'm getting what are all the values of x, and I'm storing in this vector, and I am evaluating the sign of x at each and every value in x, and I'm storing it in y1, and similarly I'm storing it in y2 for cos x and sin x plus cos x in y3. Now in MATLAB, whenever I want to get a plot, it will be good to give this command, create a figure, like figure semicolon. Now we will see uh, like when we go to multiple commands, this will be very helpful. If we have a single plot, it won't be that much helpful, you can say. But like I want to plot these three plots in a same graph. Okay. So first I'll plot x and y1, and I'm using r dash, which means that red solid line will be plotted for sign of x. And after plot, I'm using this hold on command, hold on semicolon. It means that you are telling MATLAB to, okay, now you, whatever the plots which I'm generating after this, add this to the same plot. So I want to plot cos x also in the same plot, and I want to plot sin x plus cos x also in the same plot. So now after that, I'll remove the hold. It means, okay, after that, whatever the plot if you give, it will be plotted in another figure, okay, or another plot. So then you have to give the axis label, and whatever in the brackets you write, it should be in the apostrophes like this, inverted commas, because it is a string. You are defining the label of the axis y, label of the axis x, and you are also getting the giving the title, and you also want to give the legend. So legend is, so we have three plots accordingly, like 1 2 3 you have to write sin x. First is sin x you are generating, second is cos x you are generating, third is sin x plus cos x you are generating. So these three are legends, and you are also giving the location of the legend where it should be placed. So here, if you write location and you are writing, we are writing best here, it means that it will put the legend at some best probable location in the graph, so that it won't come on the plot itself. So instead of that, you can write northeast, north, or south, or southwest, whatever the position you want to put. And I am also giving the limits for my x-axis and y-axis. So x limit is -2 pi to 2 pi, and y limit is -2 to 2. So now let's run this code and let's see how it will look. So now you can see, I hope you can see this, right? You can see the plot. Somebody please answer.
Yes, sir. Yes, sir.
Yeah. So
Yes, sir.
so we have generated a plot here, and you can see that all the three plots I have plotted in the same thing. So you can also see I have I wanted grid lines, so I have put this grid on. So if I don't use it, I won't get this grid lines. And as I have said, my x limit is -2 pi 2 plus 2 pi, and y limit is -2 to 2. I have put this and I have generated this beautiful plot which I want to plot. So now what another case is like if you want to plot three plots separately but in the same figure. So let's see this code. So as I've said, it's best practice to write this command CLC and clear before running any code. So now I have done the same thing, but you can see up till this point, everything is same in the previous code and here. But now what I am doing is I am using this command subplot. So subplot 311 means I am dividing my plot into three rows. So first row will be sin x, second row will be cos x, and third row will be sin x plus cos x. So and in this subplot also, we only have one column and it is also a first plot. Okay. So that's why I have to use this if I want to draw subplots. Okay. So first plot you are drawing. Similarly, you are giving X label, Y label, title for the first plot. Second subplot you have to define 3, 1, 2. So you can see in this three plots, as I have said, three, and only one column is there. And in my subplot, this is the second plot. Similarly, here you can see, so three rows are there, and we have one column, and in this plot, in this subplots, this is the third figure. So if I run this, all this code, you can see this kind of plot. So you can see that I have generated a plot which has three rows, 1, 2, 3, and it has one column and it has three figures. So that's why this format comes 3, 1, 2, 3, 1, 1, and 3, 1, 3. So you can generate three separate plots for each function, sine, cosine, and cos. So because I have not given limits here, MATLAB has all automatically given some limits to the plot. You can also use you can select the plot. You can also edit here also. So axis properties, figure properties. You can use this user interface also instead of using the commands also. Like you can also if you want to increase the line thickness, everything you can do in this figure window also. Okay. So now let's say if you like instead of draw like getting subplots, I want like multiple figures. Like I don't want all the plots in same thing. So now what I have to do is I have to define figure and I will draw the first plot and it is done. Then second plot, which is the cos x plot, I want to draw in another figure. So this will open another figure window separately, not in the same plot, but in another plot. So again, I'm giving figure here. Instead of this, like you can also give one figure 2 and like this figure 3. And you are plotting the different plots here. Okay, giving the axis, title, and label, everything is done. Now I'll also write CLC here and I'll run this. Now you saw that the subplot was also generated because I haven't closed that plot. So I want to close the previous figures which I have drawn. So that's why I have to write this command also, close all. so that it closes and evaluates all the plots freshly for this program. So if I run this, you can see I am getting 3 separate figures. So figure 1 is sin x, figure 2 is cos x, and figure 3 is sin x plus cos x. So in this way, I can generate multiple figures or multiple plots separately using this uh, commands like figure 1, figure 2, and figure 3. So this is how we will generate like a different different commands, different plots in MATLAB. So there are a lot of other things also, like you can generate bar plots, you can generate 3D plots. So we will see like different things as we go on. So I think this will be enough for today. Like whatever we have thought is a complete, like I think there are some things like cells and structures which won't be useful that much in this course. But you can like watch them again. I like time is up. So
Excuse me, sir.
yeah.
I have got just 2 queries.
Yeah,
Can you
sure.
go to the first plotting, sir? First plotting.
First plot, right?
Just
Yeah.
demonstrated where you have given legends, no?
First
Before
plot.
this,
Yeah.
before
Yeah.
subgraphs.
Yeah. Legends. Yeah.
Uh, Sir, that's what, sir. This location, you're saying something of this location in base which was not displayed.
Okay.
What was the
I'll,
reason, sir?
yeah. I'll just run this again.
Yes, sir.
Hold on. So you can see, right, in this figure, this location, MATLAB is automatically determining the best location for this legend. So you can see that it is not coming on this plot. Legend is put on this like north, like north east location. Like it has determined the best location for this legend, so that it won't come on top of this. Let's say I want like uh, I'll say south and just write south and I run it. You can see that here the legend is printed in the south of the plot. You can give like different like here if you want to plot it here, you can give northwest. If you want to plot it here, you can. If you want to put the legend here, you can put southwest. So if there are like different things, if you want to get whole, so whenever you are like stuck with something, some syntax of some function, you can use the help command and you can give the function name, and it will give MATLAB will try to give the documentation of this. So like everything, like you can read and get determined. You can determine the thing. So here you can see the location. So it sets the location. For example, location northeast positions the legend in the upper right corner of the axis. Specify the location of the input arguments. So these are my input arguments, and after that I am like specifying the location. So if you want to read like more the documentation about this, if you click this, it will direct you uh, to MATLAB's website documentation, and here we can read more about this. So this is the location, and you can see different locations you can put. So south, north, south, east, west, northeast, southwest, north outside, above the axis, below the axis, to the right of the axis. So like different locations, wherever you want to put, you can put. So this is one way of like uh, checking things. If you don't know something, like you can just write, run this command help and whatever the function which you want to get the help for. Otherwise, nowadays it is very easy to go to ChatGPT and ask like, what is the syntax of legend, writing a legend in MATLAB, and you can ask it some, you can ask the specific questions. It will explain you very clearly. Like you won't need to go through entire things, like do this thing. So in this way, like using ChatGPT in this way is like very smart. Instead of using the whole documentation, like it can be very difficult to read, uh, huge documentation of MATLAB. So things can be uh, simplified using these AI assistants. Okay, right?
Yes, sir. One last doubt.
Sir, Google Lab and MATLAB are same.
No. See, Google
Oh,
Collaborator you can use for Python or some open source things. I think Python only. Like
okay.
MATLAB, you have to go to the MATLAB site. Like if you have access through your institute, you can use MATLAB directly using the license, institute license. Otherwise, you can use it for free, like for 20 hours per month. You can use like online. You can code in the server. It runs and it will give you code. You don't need to install anything. So otherwise, like it's not open source. Like you cannot use it anywhere. Like MATLAB, you have to run in MATLAB.
सर दोनों में डिफरेंस क्या है MATLAB और कोलैब में?
MATLAB और
कोलैब में गूगल का कोलैब है ना?
गूगल कोलैब में आप पाइथन या जैसे ओपन सोर्स लैंग्वेज ऐसे, या जूलिया या कोई C++ ऐसे प्रोग्राम्स लिख सकते हो.
ओके ओके
मैटलैब को रन करने के लिए, मैटलैब प्रोग्रामिंग करने के लिए आपको मैटलैब का सॉफ्टवेयर डाउनलोड करना पड़ेगा, या आपको मैटलैब का साइट पे जाके डाउनलोड करना पड़ेगा, क्योंकि मैटलैब एक पेड सॉफ्टवेयर है. आप कहीं पे भी ऐसा नहीं यूज कर सकते, ओपन सोर्स नहीं है.
ओके आर स्टूडियो जैसा है?
हाँ, आर स्टूडियो, हाँ, आर भी, आर इज ऑल्सो प्रोग्रामिंग लैंग्वेज. आई थिंक इट्स ओपन सोर्स. सो मैटलैब आपको यूज करना है तो मैटलैब आपको पैसे पे करके लाइसेंस खरीदना पड़ेगा और उसके बाद सॉफ्टवेयर डाउनलोड करना पड़ेगा. या आपको फ्री में यूज करना है तो वेबसाइट पे जाके आप मैटलैब का वेबसाइट, ऐसा मैं दिखाऊंगा आपको. गो टू मैटलैब्स वेबसाइट. Here, if you go to MATLAB's website, here you can select India and sign in करके आपका जो स्टूडेंट आईडी या जो भी है, या आपका जीमेल आईडी से साइन इन करके आप ऑनलाइन में कोड करके रन कर सकते हो. छोटे छोटे प्रॉब्लम, these problems which we are teaching in our course, like these can be run on this site. But otherwise, if you are like solving complex problems, like you have to use this MATLAB, you have to download MATLAB and you can run in this software only, software provided by MATLAB. So this is the thing. So
और tomorrow same link से login करना है कि?
Yeah. Next class में like it will be say on Tuesday again from 7 to 9. Next session, and also you have other sessions like taken by some other TAs. I think one session is on Friday from 6 to 8, and one session is on Monday from 6 to 8. You can join those two sections. Those two sessions also. Like if you are not available for this session on Tuesday, you can join that also.
Okay.
Sir.
Sir,
one last doubt. Actually, in sir's class, he just ran one code. I have a doubt on this. The code is A is equal to 2:2:20.
2:2:20. Yeah, okay.
Then A greater than 10. So we got the values. Whenever it is less than 10 or equal to 10, it is 0, 0, 0. And whenever it is more than 10, we got 1, 1, 1.
Yeah.
I think 1 is for true and 0 is for false. Am I right?
Yeah. True and false.
Then the next code was A and within the small bracket, sir wrote a greater than 10.
A greater
And
than
we
10.
got answer to be empty. That one line was not. I have a doubt, sir.
A.
Shall I repeat from the beginning?
This is I'm writing it here. Can you see?
Yes, sir. I can see.
Yeah. Yeah.
Then it was a greater than
10.
10.
Right.
No, without any bracket. Without any bracket.
Ah.
Sir didn't give any bracket. A greater than 10.
A greater than 10. Sorry. I think you have to. Yeah. A greater than 10. Yeah.
So this
Means
was then we
logical
have clear. Now next code is A within the bracket A greater than 10.
A greater than 10. Yeah. Okay.
Then enter.
So
what is
so this code is giving you the values of A, the values of A, vector A, which are greater than 10. So here you can see the values of A which are greater than values of A which are greater than A are 10 are 12, 14, 16 and 18 and 20. So you are accessing all the elements which are greater than 10. Other elements you are not taking here. So that's what this is executing. Okay. So so if you evaluate like this, you can see this is a logical array. Logic means like whatever is greater than 10 will be 1 and whatever is less than 10 will be 0. So if you use this for accessing the elements which are getting like whatever there is 0 will be removed and whatever like ones are there like at whatever indices ones are there, all those values will be printed.
Okay, sir. Thank you, sir.
Yeah. Okay. Okay. Any other questions?
Sir, last lecture they share the M files. Can you please, because your the writing method is very good, very attractive compared to other 3 faculties. The system way you wrote. Yeah.
I want like you want me to share the MATLAB files, right? Whatever the codes I have written.
Yes, sir. Please.
Yeah. As I've shown you, right? On website you can access this.
No, sir. Whatever you wrote in your file, some of the files programming. You take previously this 3 sine, cosine, and sin x plus cos x plot. Some of the M file is there.
Yeah.
Your M file, sir. Whatever actually. Is it possible? Please say.
Yeah. I'll share this. If you click here, problem solving session recording in the website. If you click here, you'll go to this Excel sheet, and I'll share.
My question is that that is okay, sir. Only M file. Only M file, sir. I'm asking M files. Your M file.
Yeah.
Class recording.
Here I cannot share it. Can you mute it? I think echo is coming. So the thing is, like, I cannot share it in the Google chat. I don't know how to, like, in the meeting chat, I cannot share it here. So what I'll do is I'll create a Google Drive folder, and in that folder, I'll keep all these files which I have written. So all the examples will be kept. So you can access through the website. In this Excel sheet, I'll give a link. You can click on that link. You can go to the Google Drive folder and you can download the files.
Okay, sir. Thank you. Sir.
Yeah. That.
So one last question, sir.
Yeah. Please.
Yeah. Sir, as you said, that online version of MATLAB, we can do simple problems. Now, actually, no, I want to go for my research problems, etc. So the online version, whichever is there for 20 days trail, so in that we cannot think of computing the research problems.
No. It won't be possible for you. Like it will be like lot of things won't be available there. Like simple things,
Okay.
plotting and all these things, matrix operations and all you can do. But you will need some, like if you want to do, like if you are doing signal processing, you will have like MATLAB has this signal processing toolbox.
Okay. And sir,
So
what about Octave?
I think you can use Octave. I haven't used. I think you can use Octave. Like
So, we,
things
for
will be
example,
available there.
yeah,
Mm,
because one more lab course also I have enrolled. There,
mm.
sir was teaching about sims
Yeah,
variables.
yeah.
So it was not possible for me in the online version. So then I went
Yeah,
to
yeah,
Octave.
yeah,
Then I was able to run. So can
yeah.
I expect that my research problem, if at all I want to run in Octave, I can. It will be handy.
Yeah, it can be handy. The thing, only thing you have to remember is some, like everything will be similar. Mostly everything will be similar. There will be some commands which will be different in Octave, I think. So take care of that. Like I think you can just go to ChatGPT and ask, like, this is my MATLAB command, convert it into a thing which Octave can run. So
Okay, sir. Thank you, sir. Thank you very much.
yeah,
Sir,
okay.
maybe I am also scholar. Maybe in university they will provide all those things, huh?
I think if you are in university, like I don't know, like. I don't know, like depends on the university. Some universities provide MATLAB access, like because it is very costly. Like uh, some universities cannot. So I think you can go and ask them if they have the access, then you can use it. Otherwise, as I have said, you can use Octave. So you can download Octave and you can use it. Free version.
Okay, sir. Thank you, sir.
Yeah. Okay. Anything else? Does anyone have any question?